I'm B. Vijay Bharati, Assistant Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Salem. Now I am going to take game theory and strategy. Game theory. What is meant by game theory? Game theory is the study of how people interact and make decisions. This broad definition applies to most of the social sciences, but game theory applies mathematical models to this interaction under the assumption that each person's behavior impacts the well-being of all other participants in the game. These models are often quite simplified abstractions of real-world interactions. Next, history of game theory. Game theoretic notations go back thousands of years. Modern theory credited to John von Neumann and Oscar Morgenstern, 1944. John Nash, A Beautiful Mind field, generalized these results and provided the basis for the modern field. Next, definition of game theory. The interactive situation specified by the set of participants, the possible courses of action of each agent, and the set of all possible utility payoffs is called a game. These agents playing a game are called the players. In a competitive situation, the course of actions, that means alternatives, for each competitor may be either finite or infinite. A competitive situation will be called game. Next, basic terms related to game theory. What are the basic terms we used in the game theory? First one, players. Second, strategy. Strategy can be classified into two types. One is pure strategy and second one is mixed strategy. Third one, optimum strategy. Fourth one, value of the game. Next, last one is payoff. Game theory assumption. What are the assumptions we make in the game theory? First one, each decision maker has available to him two or more well-specified choices or sequence of choices. Every possible combination of plays available to the players leads to a well-defined end state. That means win, loss, or draw. That terminates the game. Third one, a specified payoff for each player is associated with each end state. Next, fourth one, each decision maker has perfect knowledge of the game and of his opposition. And the last one is all decision makers are rational. That is, each player given two alternatives will select the one that yields him the greater payoff. These are the assumptions that are made in the game theory. Next, uses of game theory. First use for the economics, innovated antitrust policy, actions of radio spectrum license for cell phone, program that matches medical residents to hospitals. For the computer scientist, new software algorithms and routing protocols, game of AI, that is artificial intelligence, military strategies, nuclear policy and notions of strategic deterrence, sports coaching staff, run versus pass or pitch fast balls versus sliders. For biologists, what specific have the greatest likelihood of extinction? These are the uses of game theory. For game theory, our focus is on games where there are two or more players, there is some choice of action where strategy matters, the game has one or more outcomes, for example, someone wins or someone loses. The outcome depends on the strategies chosen by all players, there is strategic interaction. What does this rule out? Games of pure chance, example lotteries, slot machines, strategies does not matter. Game without strategy, interaction between players, for example, solitary. For game theory, our focus is on where two or three. Next, for elements of a game, the players. What are first one? Player. How many players are there? Does nature, chance play a role? Next one, a complete description of what the players can do, the set of all possible actions. The information that players have available when choosing their actions. Fourth one, a description of the payoff consequences for each player for every possible combination of actions chosen by all players playing the game. A description for all the players' preferences over them. Next, zero sum versus non-zero sum. What is mean by zero sum and versus non-zero sum? In a zero sum game, a player gain is equal to another player's loss. That is, gain is equal to the other player's loss. In non-zero sum game, a player gain is not necessarily equal to another player's loss. This is zero sum game and non-zero sum game. 2% zero sum game. Payoff penalty table, zero sum table, shows offensive strategies in rows versus defensive strategy in columns. Gives the gain of row player, loss of column player. Of each two decision makers, benefits are completely opposite. One person's gain is another person's loss, possibly strategy encounter. For example, athletic strategies we take in a row strategy, manager strategies in a column strategies. We are taking this amount is the strategy penalty game. 2% constant sum game. For any strategy encounter, the row players payoff and the column players payoff add up to a constant C. It can be converted to a 2% zero sum game by subtracting half of the constant from each player payoff. Example 2, 2% constant sum game. During the 8 to 9 p.m. time slot, two broadcasting networks are vying for an audience for 100 million viewers who would watch either of the two networks. Payoff of the two networks of the 100 million. Network 1, Western soap comedy. Network 2, Western soap comedy. So these are the frequencies that are played in the two networks. Here the problem is given. Next, an equivalence of zero sum table, network 2, network 1. So we have to minus the against the network 2 minus network 1, we get the results. So equilibrium point in a 2% zero sum game, if there is a payoff value P such that P equal to maximum of row minimums and equals to the minimum of column maximum. If you are taking the minimum value in a row, and which one is the maximum value we get. And then we take the maximum value in the column and we get the value of minimum of that. That both are equal, then P is called equilibrium point or saddle point of the game. Maximum of row minimums equals to the minimum of column maximum equals, then the point is called saddle point of the game. This is very, very important. The prisoner and demon game. Two players, prisoner 1 and 2. Each prisoner has two possible actions. Prisoner 1, don't confess, confess. Prisoner 2, don't confess, confess. Players choose action simultaneously without knowing the action chosen by the other. So both the players don't confess, confess. And prisoner 2 also choose don't confess, confess. So payoff consequences quantified in prison's years. If neither confesses, each gets 1 year. If both confess, each gets 5 years. If one confesses, he goes to free and the other gets 15 years. Few years equals to greater satisfaction that is given by the higher payoff. Prisoner dilemma in normal or strategic form. Don't confess, confess. Don't confess, both are getting don't confess, then get 1 year. Don't confess and confess, prisoner 1 getting 15 years and prisoner 2 get 0 years. If confess and don't confess means prisoner 1 gets 0 years and prisoner 2 get 15 years. Both are confesses means both can getting 5 years. This is the game theory, strategy, row wise and column wise. Prisoner dilemma in extensive form. Prisoner 1, don't confess, confess. Prisoner 2, prisoner 2. Don't confess, confess. Don't confess, confess. The payoff matrix is given here like this. Prisoner's dilemma, example of non-zero sum game. A zero sum game is one which the players' interest are in direct conflict. Example in football, one team wins and the other team loses. Payoff sum to 0. A game is non-zero sum if the players' interests are not always in direct conflict. So that there are opportunities for both to gain. For example, when both players choose don't confess in the prisoner's dilemma. Okay, thank you. Thank you for watching.